Hello and welcome to Aughton Math. In this edition of Aughton Math, we're going to talk about and do some problems involving adding and subtracting polynomials. In the first problem, we're asked to find the difference of the two polynomials, and then we're going to enter our answers as a sum of the coefficients of the difference. Now, the reason why I do this is I have a device that the students enter their answers into, and this is the way that I collect their data. But otherwise, we'll just go through a couple steps. Now, there are two ways that you can subtract one polynomial from another. You can handle it in this operation vertically, where I leave the negative sign here and then I subtract these terms. Or I can change the terms for the values which you're subtracting into positives, or change them by distributing the negative sign and then adding the terms together. So let's go through an example of what that might look like. So first, let's just subtract all of these terms from the top values. So I have 5 minus a minus 4, which gives me plus 9. I have minus x minus 7x, which gives me minus 8x. I have minus 8x squared minus 0x squared, which gives me negative 8x squared. And I have 4x cubed minus 2x cubed, which gives me 2x cubed. Now the other way to go about doing this is to remove the parentheses here and distribute the negative sign, and then to add the two values together, two polynomials together. So I have 4x cubed minus 8x squared minus x plus 5. And then on the bottom I'll have negative 2x cubed minus 0x minus 7x and then plus 4. So I'm changing the signs. And now I'm going to add the two terms together. I have 9 minus 8x minus 8x squared. And then here I have, in the x cubed column, I have 2x cubed. So this is my result. And you can see that these two results are the same regardless of the way that I handle this operation. Either I could subtract the entire polynomial, or I can distribute the negative sign throughout or across that polynomial and then add. In the second and third questions, I'm asked to use the process of adding two polynomials horizontally, and I'm going to handle that for the first two questions. So in the first case, I'm going to add the two polynomials horizontally, and what I do is I align the like terms and I add them together. So I have 9b squared plus a negative 5b squared, which gives me 4b squared. I have plus b minus 2b, or plus and minus 2b, which gives me negative b. And then I have plus, or minus 2 plus a positive 8, which gives me plus 6. And that's my answer. Now when I take the difference, what I'm going to do is I'm going to remove the parentheses from the first. And when I do that, I don't have to change any of the signs of the terms. And then I'm going to remove the parentheses in the second polynomial. But when I do that, I have to change the signs because I have a minus 2x squared, which gives me plus 2x cubed. So remember, you have to distribute this negative sign. So I have plus 2x cubed plus 3x squared, and then minus 3x. So now I combine like terms. I have 3x cubed plus 2x cubed gives me 8x cubed, plus 5x squared plus 3x squared gives me plus 8x squared. Minus 10x minus 3x gives me minus 13x. And then I just have simply plus 1, and there's my answer. Okay, now I'm going to find the product of the two polynomials, and I'm going to use the process of multiplying them horizontally. And I use my foiling method, but typically what you might do, instead of first outside, inside, last, if you had three terms in a polynomial, you might just want to apply the first value, first term, to the first term in the second polynomial, first to the second, and then first to the third, and go through this process, second term to the first term, second term to the second term, and then second term to the third term, and find the products that way. So in this case, I have 8z multiplied by z gives me 8z squared. Outside 8z plus 1 gives me plus 8z. Inside minus 5z, and then last minus 5. So I end up with 8z squared plus 3z minus 5. All right, in the second expression, I'm going to find the product of these two polynomials. I multiply h by h squared. I get h to the third. H times 2h gives me plus 2h squared. H times negative 8 gives me negative 8h. Negative 3 times h squared gives me negative 3h squared. Negative 3 times 2h gives me 6h. And negative 3 times negative 8 gives me positive 24. Now I combine like terms. I have h to the third. That's the only cubed value. So h to the third plus 2h squared minus 3h squared gives me minus h squared. Minus h plus 6h gives me minus 2h. And then I have plus 24. So my resultant value is h cubed minus h squared minus 2h plus 24. All right, finally I want to write the area of a polygon as a polynomial in standard form. So simply I have 1/2 base times height is my value for the area of a triangle. So let's multiply out the values of the height and the length first. So I have 2x minus 4 times 3x minus 1, and then ultimately I'm going to divide this all by 1/2. But I'm going to take care of these two polynomials first. So I have 6x squared minus 2x minus 12x plus 4, and then that's all going to be divided by 2. So I get 3x squared minus x minus 6x plus 2, which is the same as 3x squared minus 7x plus 2. And that is the polygon as a polynomial in standard form. So remember, standard form ax squared plus bx plus c is my standard form. Okay, lastly, I think that's it. Thank you very much, and I'll see you next time on Otten Math.